Welcome to the Virtual Foundry Podcast.
Hi, everybody. Welcome to the Virtual Foundry Podcast. This is Volume 2, Episode 18, our last episode of year 2021. Today is Friday, December 31st, 2021. The time is 10:41 a.m. and the temperature is 28 degrees Fahrenheit here in southern Wisconsin. That's -2 degrees for you Celsius users. We're well into winter, colder temperatures, and lots of snow ahead. Very standard winter in Wisconsin ahead of us. Today, we're going to be answering that question: who uses filament? Who is working with this stuff and what are they doing with it? I'm Tricia Cease, president of the Virtual Foundry, and with me as always is Brad Woods, our founder, inventor, and all-around science guy. Say hello, Brad.
Hello, everyone.
So, Brad, today we're talking about who in the world is using filament and what are they doing with it. And the easiest group of our partner innovators to talk about is universities. So colleges and universities, tech schools all over the world are using filament for different things. Sometimes that's just a tool that's available in the lab for students to use as they choose. Sometimes it's a part of college coursework curriculum. Sometimes students are doing their master's or doctorate projects with it. Some of them, in that case, are just simply studying this new technology. What's it about? How does it work? What are the results? And some of them are doing special projects with it. We just learned about a paper published recently by Aalto University in Finland. Tell us about that work, Brad.
Right. Their experiment was a novel method of developing new alloys. And what they did was they took two different virtual foundry materials. They took some of our iron and they took some of our stainless steel. They then sintered them and then tore it apart, did the full metallurgical workup on it, did some microscopy. And in the end, sort of the summary of their paper was that this is in fact an excellent new method of developing compounds, alloys with well-distributed constituents, which is very, very interesting.
Yes, we were very excited to see that come through. They're printing. Lots of people have asked about multi-material prints, and this university carried it through, centered it, published a paper on it. We do learn about some of these papers that get published, and when we do, we put those on our website, and there will be a link to that website page in the description of this video. Now, locally here at home, we're working with a group of students at the University of Wisconsin-Madison on their capstone project. So it's also very exciting to be working so closely to home as well as all over the world. Now, professors at universities are joining into the fun too. So some of them are doing special projects or special research projects along with their students, and some are writing for grants, writing for funding to research new ways of doing things. One in particular is looking for new avenues in energy.
Fusion energy is what they're actually experimenting with. One of the groups is. So we have groups that are working with standard fission type nuclear reactions where the modern strategy is to make the nuclear reactors small and portable. And to do that, you need small, intricate pieces. So this has been a key point of exploration for a pretty big group of our users. On the other side of things is fusion. So nuclear fusion is so awesome that if you describe it, it doesn't sound real. Right? It's infinite energy with no waste. And it sounds suspiciously great. And the problem is, I mean, we've done that. Nature does this all the time. It's how our sun works. So we know that it can be done. And trying to create that same system on Earth has been incredibly challenging. So yeah, that one's just, it's way out in the future, but it's incredibly interesting.
So speaking of energy, nuclear energy, and new forms of creating and containing energy,
Yes.
We do also work with national labs, not only here in the US, but in other countries as well. So for example, we did create a custom material for a research center outside of the United States focused on nuclear energy. And speaking of that custom material, what that means is they came to us with a request for special 3D printing filament that we don't normally keep in stock. So can you make this special material that we want to use in 3D printing in a 3D printable format? The answer is absolutely yes. So we made that special filament for them. We're working on a custom filament for a national lab right now. There's a project in-house going on there. And speaking further about those custom filaments, we get into the arena of space as well, which is one that's very exciting for me. We've created a custom material for NASA Jet Propulsion Lab. We have an ongoing project with a company that seeks to build structures on the moon using in situ materials and our filament process to create structures on the moon. So we have made a moon dust simulant 3D printing filament for this group.
Yeah, and this is kind of interesting. I learned things about lunar regolith that I didn't know before. And probably the most interesting that people won't think of right away is it has enough iron in it that it'll stick to a magnet. I thought that was kind of shocking, actually. But at the same time, it also has enough metal and other oxides in it that will sinter. So you can sinter the lunar regolith into a relatively solid clay-like brick.
So space is a very exciting topic around here. SpaceX is a customer of ours as well. And branching further into these governmental organizations, the Department of Defense is also using our materials, the Air Force Research Laboratory, the Army Research Laboratory, and other divisions within the Department of Defense. Oftentimes, they can't tell us what they're doing with the material, so we're not able to share very much about their uses.
Right. We can say that we're doing it, but we can't say anything else. So sometimes that can be a little frustrating for nerds like me.
So another area that people really get into with our materials is in radiation shielding. Brad, tell us about this Rapid 3D Shield tungsten filament that we have in our store.
Right. So it's essentially the same as our other materials. It's metal powder loaded into a thermopolymer binder. The difference is this is powdered tungsten, and tungsten is nearly twice as dense as lead. And because of that, we're able to make a 3D printable material that has roughly the same density as lead. And this has more applications than you can think, than you would initially think. By far, the most common application for our tungsten filament is radiation shielding. And this comes into play in a lot of different ways. Sometimes in nuclear energy, but typically it's dealt with X-rays. So it's being used, or at least researched, for methods of irradiating tumors and minimizing the amount of radiation that's exposed to the patient by making a custom aperture, basically, that is exactly the same shape as the tumor. But some of these projects are like that. They'll kind of grow legs and just kind of keep going into more and more interesting applications. Another interesting application is frangible projectiles. And this is another repeating topic for us. We kind of hesitate to talk about firearms applications sometimes, but it comes up a lot. And in this particular application, you can use the tungsten to 3D print a projectile that crushes on impact and breaks into fine particulate, losing its mass immediately. So the idea is that there's no ricochet, there's no energy left in the projectile after it hits something. So this has been pretty interesting. We've had auto companies explore, not in a production way, but just testing weights in shift knobs for cars. You know, what feels the best in the hand as you're working. This has been kind of interesting. So that was an application where the tungsten does nothing more than add weight or mass, and creates a nice feel for the object. vibration dampening. This is another one, and counterbalance, things like that. Any place you need a lot of mass in a very small space, our tungsten filament is highly applicable. But the advantage is that you can print it in just any 3D printer. It doesn't take a high-tech 3D printer. It's very, very simple, very accessible.
Now you're talking about some industry applications, and we do have some partner innovators in industry who are researching things like human body implants with our titanium material and other things like that. So that is an area where continued research is happening.
Yes.
And then we get into some more lighter applications like art and music, like sculpture. For example, there's an museum in Italy that is printing replica pieces for their gift shop and making beautiful objects there.
Yeah, these are really cool. They're little bronze busts and things like that. And they just look absolutely fantastic.
And then near and dear to both Brad's and my hearts is music. So we're both musicians as a hobby, and we have some customers in woodwinds and in percussion who not only are using this material as part of their instrumentation, but also looking at different ways to make new instruments.
Right. And that's kind of the key advantage of the strategy of using our materials. It's a new way to solve all kinds of interesting problems. And as time passes, we're finding more and more people finding more and more interesting applications.
And then we get to the fun category. So if you're watching our podcast, you saw an interview with Mr. Highball. You're seeing his videos go through on our social media. He's just having a blast working with the material, learning different ways to do things, experimenting with new techniques. And our friend Aron Wayne, who visited us last summer, also just has a great time working with the material. So that's another use of the folks at home making stuff for the fun of it.
Yes. And the home projects are becoming more and more interesting. And we got some feedback from a user that actually described his motivation for 3D printing metal at home as spite, because it's supposed to be very, very expensive and inaccessible. But using this strategy, it's not. Those people can 3D print metal parts at a reasonable cost, and it isn't terribly difficult.
So our partner innovators are gathering in places like Reddit and our discourse user forums. So we're opening up the conversation to everybody. Take a look at what they're doing. Talk to us directly there. You can also talk to us directly by contacting us at info@thevirtualfoundry.com. These are other ways to join in the conversation, Reddit and our discourse user forum. Links to those resources will be in the description of this video as well. So Brad, I have one more very important question for you before we wrap up today.
Okay, I'm nervous. Okay.
Okay, how do you find Will Smith in the snow?
I can't imagine.
You look for the fresh prints.
Nice.
Now, you may need to be older to understand that joke, but if you need some explanation, email me and I'll tell you all about it. Now, if you've got a cool project, if you're one of our partner innovators, you've got a cool project you want to show off in this format, we'd love to have you as a guest on the Virtual Foundry podcast. Until then, we'll see you next time.
Thanks, everybody. All right.
I'm trying it without my glasses today. We'll see how that goes.
Let's see how much you squint. Man, I had a whole thought that just vanished.
So what's that called? Green energy.
Right.
So nuclear energy. Okay, so starting over.
Well,